So let's go ahead and start with today's session with the first topic, which is why do we need access management? All right, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server, and this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first we will create an administrator account with all the permissions. Now tomorrow, say a UI developer comes into your company, right? Now a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access, maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or each every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have two or three AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that, that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. It's more, there is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically four different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies. Right, so the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console. Right, so let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user, right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Alright, so this is what user is all about. Let me go to my AWS management console and show you how you can create a user in IAM. Alright, so give me a second. Alright guys, so this is my AWS sign in page. Alright, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. All right, guys. So you should never work in your root account. You should always have an administrator account through working. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. All right, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically two kinds of access that I can give. First is the AWS management console access, and then we have the programmatic access, right? So what is these two? If you want to, so there are basically two ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access, right? Secondly is the AWS management console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever, right? So that is called the AWS management console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also, guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. All right, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies, and since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. All right, so you can review all the settings that you did over here and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see one time, only one time when you have created your account. So it is essential that you store your access key and your secret access key once you get this page. All right, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this, so let me copy this and paste it in the notepad. All right, so don't worry, you might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. All right, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. All right, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link as of from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. All right, so I've logged out. I'll close this and I'll come here and go to this particular link. All right, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account, right? So I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on, guys. So I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. That is here. All right. So let's get back to our slide and discuss the next component. All right, so we've discussed what are users. Let's move on to the second component, which are groups. All right, so whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because, say, let's take an example. So say you have 5 users and these 5 users have to be given identical access, right? Say these 5 users belong to the development team and the developing team has to have some common access that they all will have, right? Now, one way of doing this would be that I would go to each and every user and attach a policy that they need, right? The smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy and it will apply to all these 5 users, right? So these are why groups are very important. Now how we can create groups, let me shed a light on that. So you will go to you can see you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it will ask me the policy that I want to attach to this particular group. All right, so say for example, I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, and now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test. All right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next, right? And now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. Alright, so the test account has just been created. Now as you can see guys, in the case of my account which I created, I got an access key and a secret access key, right? So in this case I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access it will give you the key so that your application can actually interact with the services that you have launched. Alright, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I'll reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say, for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right? So it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right. So that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3. And if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over there. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. All right, so let us come back to our slide to discuss our next component. All right, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. All right, so roles are similar to users, but roles are actually assigned to applications. All right, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles, roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance you are hosting your web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now if I want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service. Right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to I'll create a role type of EC2. All right, so I'll select Amazon EC2. And what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here and I'll click on next step. So it'll ask me the role name. So let me specify the role name as edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. All right, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions, I'll start this particular instance, right? And what I can do is I can attach the policy using instance settings. It says attach or replace IAM role. I'll go here, I will go to the drop down and select the role that I've just created, which is edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. Alright, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. Alright, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them, and they basically identify a particular instance or a particular person as the owner of that particular service, right? So I've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console, I'll go to IAM, right? So you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account, all right, and I will add permissions and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. Alright, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now, what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it? Right? So say I want to allow the EC2 service to this particular test account. All right, so I'll go to EC2. All right, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right, and click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy and it will create the policy for you. So as you can see, there are 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. If what if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy and I'll say deny. I'll select EC2. Right. I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it'll ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you'll enter your password, and when you click on login, it'll also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password and second layer becomes the code that you'll be entering, right? Now with AWS, there is an application called the Google Authenticator, right, which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi-factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS management console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. All right. So for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now. So I'll assign it a device. I'll click on edit. And now it'll give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. And now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. Alright, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. Right, it might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving on your Google Authenticator. So basically these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020 353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done. Right, so now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, so I'll come to my normal login page, right? So I'll enter my username and my password, which is this, and now I'll click on sign in. So now it'll ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account which I configured using the administrator account in IAM. Alright, so it's very simple, guys. You can actually get world-class security with the click of a button using IAM. Alright, so we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what you guys have been waiting for. So just give me a second so that I can configure everything on my end. Alright, so what we'll be doing now is I have created an application which can interact with the S3 service. Alright, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. and then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not. All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and that the bucket looks something like this, right? So that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects, so let's delete those objects. uh, so here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now, so let's delete these objects. Alright, so now what I'll be doing is this is the code for my application, guys. Alright, so in this code, as you can see, I have not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me quickly, so let me show you without the secret key and access key how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this, right? So I'll copy the key over here and then my secret key as well over here. And now I'll save it, and if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once, copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. Alright, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. Alright, so let me go to my EC2. Right, here it is. So remember, in the starting of the session we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. Alright, so I can access the website on my EC2. Now if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now let's see what happens if I attach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach, and now if I try to upload a file again, As you can see, I see a blank page, which basically means that an error has occurred. All right, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it'll again work. Right, I'll choose a file, say this file, upload the image, and it'll work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. It'll, if it doesn't have the key mentioned in this particular function, it'll basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there. All right, so guys, that is it for the demo part.
In this session, we will be discussing about Amazon Redshift, the most popular cloud-based data warehouse. So let me run you through today's agenda quickly. We will begin by taking a look at traditional data warehouse. We'll be discussing its underlying architecture and the disadvantages of using traditional data warehouse. And then we'll move on to our today's topic, which is Amazon Redshift. Here, we'll be discussing its architecture, its key concepts, its unique features, and the advantages of using Amazon Redshift. And finally, we'll be doing a demo on Amazon Redshift. In this demo, we'll see how to import data from Amazon S3 to Amazon Redshift and perform queries on this data very easily. So I hope that was clear to you guys. Let's get started. I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is, the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So, this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company And this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So, this US based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So, to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like that to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So, to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, autoscaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud based warehouses instead of traditional on premise systems. So, guys, in this session, we'll be dealing with one of the most famous cloud based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes, these are storage optimized and are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift, and then the complexity of the queries that you run on your database, and the need of downstream systems that depends on the results of these queries. So, keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now, we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find create a cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have three columns and two rows. The first column contains the unique number associated with student. The second column contains the name of a student, and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically, it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have three columns and two rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all SSN stored in first block, and all names stored in second block, and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment cost and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from Data Lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or data lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or data lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift data warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have three things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download, and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step one, we have prerequisites. Okay. Scroll down and it says in the step two, you have an option where you can download, go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part, scroll down, and the step 4, you can see configure a JDBC connection. Click on that. It'll take you to a page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench. A zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon management console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page, and you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user, now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need a IAM role here. In this demo, I said that we're trying to import data from Amazon S3. But you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create an IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is enough, but there is one more permission which says Amazon S3 full access, so you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2 and click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option, in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or use or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. Or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439 custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay. Then, so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay. Then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor, so I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user and the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor the earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name Archana space some age b hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back, so that's delimiter which separates the data, and this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it, and wherever this is, you need to just paste it. Control V. Okay, we're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows, so it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, the sum error, it should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you've the perfect connection from your SQL Workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users who was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore different many other features of Amazon Redshift Well, I've just showed a part of them here. So go ahead and create a database, perform